So if we start looking at problems from section 10.3 here, we're going to start off on problem number 6. Now number 6 relates back to our previous section on 8.2 when we talked about Old Faithful. And out of the 40 eruptions from Old Faithful, we talked about all this value in here. We found an R value of 0.0915. Now once again, this R value was extremely low, so we said that it was not linear. Okay, so this is one of the things. Now our linear line in the regression model gives us 119 plus 0.0331x, and then they tell us a mean of y values is 127.2 feet. Okay, so they discuss and they tell us to predict the height given that x equals 120 minutes. Okay, so we have a duration time of 120 minutes. They tell us to predict the height. Now once again, because this R value was so low, okay, so this residual value here was so low, we talked about it being not linear. Okay, so because it was not linear, we're not going to use this linear line, and we're going to have to relate to this. So we would state that our best indicator for a y value here would be our y bar of 127.2 feet. So this is our best predicted height. Okay. Number 8 talked about the serial killers. Once again, the sugars relating to the calories within here. We had an R value of 0.765, which was a higher R value than our critical value, so we deem this to be linear. Okay. Now, on here they gave us our y hat value of equals 3.46 plus 1.01x. And then they also give us a mean value of 3.76. Okay, so our y bar and our y hat. Now, because this R value was higher than the critical value, we deem this to be a linear correlation. So now we are not going to use the mean of it. We are actually going to use our correlation equation on here. So we would state that given an input of, let's see here, where am I at? 0.4 grams of sugar, we're going to now predict how many calories it's going to be. So we're going to go y hat equals 3.46 plus 0.01 times 0.4, in which then we get our y hat to be 3.86 calories. Okay, so unlike here, when it's not linear, we will use our mean of our outcomes for any input. So this was 140, 200 million. That would be a case in which they'd be like, well, 200 million is quite a ways out from what's given here, so maybe we got to relook at that. So we wouldn't use either. But if we had 200, 180, 60, they're probably very close to what our inputs are, so then we would use the mean here. Now down here, because we deemed a linear correlation, this 0.4 is actually going to go into our linear equation for our input to give us our predicted output. So as this number of 0.5, 0.6, our outcomes would change in this case. It's just something to be referencing towards. Number 14. Remember, number 14 related to the PSAT and the SAT test. Okay, if we think back to what we had, let me just bring back my calculator. If we bring back our calculator right here, we talked about we had a p-value of 0.164. We talked about our t of 1.58, r value of 0.543. So in this case, we deemed it to be not linear. Okay, so something to be thinking about on here. I'll be thinking about the whole situation. Let's see if I can bring this in so you can see it a little better. If we think about right here, it gives us our regression equation. instead of using b naught and b1, it says a plus bx. And then down here it defines a and b. Okay, so what we would do here is we would say that y hat equals a was 1,313 plus, then we had b was 4.56 x. Okay, so if this was a linear equation, this would be the line we would use. But because of how the situation's going, we don't necessarily have that information. So if we remember back, we deem this to be not linear. Okay, so because it's not linear, we can't use this equation. Now do realize the section asks us to write the linear regression and then to conclude the best indicator. So the best indicator is going to be y bar in this case. So what we need to do here is we need to find the mean of this. Now, we could type in each of our SAT scores and go from there, but do realize we have all that information in our calculator under that SAT. We need to take the mean of this. So if I go menu, statistics, stack calculations, and then just one variable, and I bring in my SAT, notice here it gives me my mean value for my SAT column. Okay, so I have 2152.5. Okay, and we would deem this to be our best indicator on this topic. Once again, just because it's not linear. If it was linear, we would plug in whatever it is. Now, do realize it's asking us for a 229 PSAT. So it says that if you get a PSAT test score of 229, we want to predict what your SAT test score is going to be. Because it is not linear, we can't use this equation where we plug this in. We would say, well, your best indicator is going to be 2153, taking just the average of this. Now, is it really accurate? Once again, the data was voluntary and doesn't really work towards what's going on. So let's consider a completely different problem. Okay. If I come down here, we can probably see it the best, just so I don't have to zoom in and out. So we're going back and forth. So we're going to go home. We're going to go to a new document, and I'm going to do this one fully with you, kind of walking you through. No, I don't want to save. Okay, new document. Don't save any changes. Bring in a spreadsheet, and we're going to look at number 18. Okay. So number 18 is what we're looking at. Let me write that number up here. Okay, so on number 18, they talk about auction bids, and they talk about an item not included in the table is a pair of New York Knicks tickets. The auctioneer started the bid at 300. The best predicted winning, or find the best predicted winning value if the result close to the actual bid of $250. So we talk about an opening bid. So I'm going to go open, and then what the closing bid is. Okay, so we have our closing bid, SE. So if we think about an auction, auctioneers always start the bid high in hopes that somebody's going to jump into it, and so they can get more money, but a lot of times they back way down, and then they build it back up, and they meet somewhere in between there. So they might start the bid off at $1,000, then they'll drop it down to $500, and then settle for $650. Okay, so that's kind of what's going on in this scenario. So if we go through and we type in our opening bids, we have a $1,500, $500, $500, $400, and $300 items. So we have 5 items in here. And then that $1,500 one sold for $650, $175, $125, $275, and then $125. Okay, so if we're considering what's happening in here, it tells us, do we have a linear correlation is one of the biggest things we have to deem on here. So we got to kind of go back, being we didn't previously work this problem. We got to deem, is this a linear correlation? So if we go bring in a calculator into this, we'll go menu, statistics, stat tests, looking at our linear regression t-test. We are talking opening bid as our input. The closing bid is going to be the outcome then. We see an R value of 0.946. Okay, so we see this R value, 0.946. If we were to consider what's happening back on our R values itself, we would have 5 items, so we would see 5.878. We are definitely higher in that critical area. So yes, this is linear. Okay, so I'm just going to go like this. I'm going to go linear. So we can use a linear regression model. So if we come up in our problem here, we would state that y hat equals a, which was negative 4.62, and then plus b, which is 0.429x. Now that we have this, we could find the mean. Okay, so we can always go back on any problem. I would tell you, if you were time crunched, we deemed it was linear, so we can just stop here and use our linear equation. We don't need the mean, but once again, so we can see this, our mean, closing bid, was $270, okay, dollars. So we're deeming that, let's say we started the bid at $300. Okay, so if x equals $300, we would now have to decide, do we have a linear correlation or is it not linear, in which then we would use the mean. In this case, because this R value and what our residual is telling us, we have a linear correlation, so now we're going to use our y hat line. So we'd say our best indicator is going to be this, where now we would plug 300 into here. So we see that we would get $124. So this would be our best indicator. Now, because the actual, okay, so the actual came in closing at $250, we would see that our predicted value is actually not close. Our mean was a better indicator in here for some reason. Now do realize some of this does come into play, that this opening bid came in really close where all our other ones were pretty far away. So maybe they didn't space it out as much as they used to with some of the other ones. But this is what we get into when we start talking about, are we going to consider the linear prediction or do we have to take the mean? Once again, is it a linear model or is it not? So we have our two problems here. If it's not linear, we're going to use the mean of our y values to best indicate what's going on. If it is linear, then we're going to use our actual linear regression equation. We're going to plug our value in for x, and we're going to state this is. Now, do realize this is a prediction model. It's never going to be perfect. It can't be fully accurate. I mean, it would be great if we could, but it's just a prediction, so there are so many unknowns that could happen in here that really could cause issues, but we have to use what's best for our statistic modeling.